Okay, it is time. Good afternoon. Thank you for coming back. Modern methods for transport of media. Same as this morning, Andy Gladding is not here today. He got injured at work, and so next year, we promise. But his topic, I'll cover that afterwards. Right now, to start through this, we got Jim Stagnito, New York Public Radio. He's Director of Engineering. Jim has the distinction of working for a few dozen radio stations in his career in the shortest period of time without leaving his desk. Say that again.
Most of those stations were the same one.
Yes.
They just kept getting sold.
They just kept
changing call letters.
Yeah, all through consolidation. So Jim works with Steve Schultes, who was on earlier as Director of Engineering, New York Public Radio, and his experience through transport of media, I think, will be relevant, and we'll do a little bit of a tour from the way it was to the way it is now. And then, of course, Sam Wallington, who is president of his own company, Wallington Systems, formerly vice president and a big title at EMF, K-Love, and Sam has ventured out onto his own. And I would suggest if there's any project you need help with, he's your man. Even though he's in Tennessee, he made it up here yesterday morning and spent a full day at the Empire State Building, and he's still standing to talk about it. He was able to sleep last night, and here he is. So even did a little troubleshooting yesterday, too. So, but let's get started here. Modern methods for transport of media. We're going to start with Jim Stagnito here. And Jim will go through his part of the presentation here, which I've seen, and this is going to be fun. Be nice to Jim.
They better be nice to you after I get done with this. Hi, everybody. I hope everybody enjoyed their $50 lunches. The name of this session is Modern Methods for Transport of Media. Modern methods. But yet when this guy asked me to participate in the session, he said he wanted me to talk about old stuff. And I mean really old methods of getting program content from point A to point B, specifically for radio. So we talked about it, we argued about it, and then it finally started to make a little bit more sense. We want to see where we're going. But before we can do that, we have to see where we've been. So I guess Bud figured that I'm the guy to do it because I come from a time when you didn't need Cisco certification just to be a broadcaster. So the past is prologue. Let's go forward into the past. Pretend it's 1965. All right? You're spinning the hits. You need to establish a fixed location, point-to-point STL between your studio location and your transmitter. The endpoint, it could be a transmitter site, it could be a production facility. Back then, a radio station had a very limited number of choices. It all depended on your technical situation, your budget, and, just what was available at that time in your location. Your first choice would have likely been a leased telco connection. For an AM station, it would have probably been an 8 kilohertz equalized phone line, and for FM or production use, it would have been a 15 kilohertz equalized line. The telco provider would have probably used a device like this repeating coil to equalize the line into some semblance of broadcast quality. And for many years, the 111C, I keep pointing there, that's where my screen is, that's where your screen is. It's the kind that was accepted for just about everybody. The circuit provided, The circuit provider would have probably used a device like this. It provided monaural audio, and when installed and adjusted properly, it provided reasonable frequency response and distortion numbers for the time. Now, if you wanted two circuits matched for stereo operation, that's where the fun began. There's no guarantee that just because the engineer ordered what they called a matched stereo pair, or a golden pair as it was called here in New York, that the phone company would be able to provide that. The second line could be routed through some other central office than the first, or both circuits would be equalized in a similar manner, but somehow they just didn't sound the same. So the result was sometimes there would be some pretty bad phase or frequency response discrepancies. The stereo imaging could be all wrong. Your mono signal could be disappeared if they flipped the lines 180 degrees anywhere in the circuit. Amplifier gain settings could be wrong. This was always the problem with this kind of circuit. You're relying on a third party to consistently get all the moving parts right. And as for trying to get that third party to fix the problems, especially if your signal had to be routed through central offices before reaching your endpoint, well, let's just say that you needed to be tenacious to get through to the proper parties who could fix your problem. The fix wasn't instant, and it was pretty much out of your hands. Well, one way to control the quality of the STL signal and skip that third party was the use of point-to-point microwave radios. Under Part 74 of the FCC rules, the use of 950 megahertz microwave STLs began in the 1950s. These links offered a lot of flexibility and are extremely reliable, and they are still in use today. I bet you somebody here in the audience is using that as their primary as well. We're using them as backups. So these could be monaural links. They could be stereo links if you use two, or if you used a system that could transmit the stereo FM composite signal, main channel, sub-carriers included. Now remember, right now, we're still talking about being in a total analog bubble. The system is unidirectional, Studio 2 transmitter. If you wanted a duplex system, so you can get remote control telemetry or IFB, something like that, then you need to make other arrangements. You'd wind up having to order another phone line coming back, or if you had the money and the space, you could set up a 450 megahertz TSL transmitter to Studio Link. By the mid-1990s, digital STL systems were introduced, and they were all using audio compression algorithms to transmit audio as serial bit streams. This allowed for multiple audio channels to be transmitted. So, for example, if you had two radio stations that you owned and you wanted them both to send their signals to a co-located transmitter site, you could do that on one rig. Many stations in New York City are using these systems as backup STLs to this day. They're still simplex, and in these systems there isn't much of a data rate, so you just have to choose what you send wisely. In the 1980s, radio broadcasters began to use T1 multiplexers to carry programming and data. Now, I know the technology was nothing new at that time. The phone company had been using it for years. A T1 circuit had a bandwidth of a little over 1.5 megs, split into 24 channels using TDM. This allowed the user to configure the equipment to meet their own operational needs. For example, the MUX modules could be set up so that one audio stream could have a higher audio quality than the other by using more of those 24 channels. And it was duplex. Big plus. There we go. Now, different MUX manufacturers had some unique feature sets. Some offered modules that used different flavors of data compression to make better use of the limited bandwidth that was available. And this manufacturer for that picture was rather unique. They had a system that allowed you to transmit FM composite over the T1. T1 could be used as a leased telco system, which eventually got to be very expensive to use, as the phone company wanted those wires. They wanted to read that price you out when the time came. Fortunately, the T1 could also be transmitted over an RF system. So far, the topic has been on legacy STL systems. Are we all still here? Okay. Well, what about remotes? Still got to do remotes. You still need equipment for remotes. So let's take a look at some of these boat anchors. You had mixers that could be connected to leased telco lines, Marty remote pickup microwave systems, 3 POTS line audio extenders, leased ISDN circuits, single line POTS codecs that could deliver a duplex 8 kilohertz audio signal over a single POTS line, to ultimately IP codecs, sometime bonding streams for better bandwidth or better signal efficiency, your choice. The age of the IP codec came to our corner of the broadcasting world in the late 1990s and the early 2000s, in lots of different flavors, lots of different capabilities, starting as single-channel duplex devices and then evolving into the multi-channel Swiss Army knives of audio that we use today, capable of audio and data rate transfer that would have been considered science fiction to radio broadcasters back in 1965. IP-based STL systems have the most flexibility in how they can be connected and configured. Over these systems, you can have multiple bidirectional audio and data streams. You can remotely control your transmitter site systems, provide Ethernet connectivity to your remote control locations, establish either wired or wireless networks, and much, much more. Like I said before, the past is prologue. This little trip down memory lane was our attempt to remind you of just how far we have come in the transport of media for broadcast in a very, very short period of time. Coming up next, where we are now, some possibilities for the future as well. So thank you for your time, and here's Sam.
Thank you, Jim. As Bud mentioned, I am no longer with EMF Caleb, but I did reach out to them and got permission to share because I think it makes a good case study, kind of a good example of how we got from here to there. So as Bud was saying, when I started doing contract work with EMF in 1988, it was just a few signals scattered all over the West Coast. They were all fed via some analog method. Equalized lines, like we were talking about, 950 meg STLs. And my favorite, almost everything, a lot of other things were fed off air, but my favorite was fed off air to a TV subcarrier, then off air again to something. I mean, it was pretty bad. But we made it through that era, and we're able to get there. And then we moved into in '92, installed satellite uplink, and went to an SCPC satellite-based system. Finally, we could get from point A to point B without quite as much pain. Instead of the long-haul microwave we were using to get signals from Northern California to Southern Oregon, we were suddenly able to do it really easily. And what the beauty of that was it made it possible to add new signals really easy. Plant a dish, point it, and you're on the air. Didn't have to call anybody, didn't have to complain, whatever. And at that point, landlords didn't really care. They didn't even charge rent for the dishes. That was nice. It doesn't work that way anymore, but SCPC is still in use. It still works. It's still good quality. It'll do a great job of submitting signals to lots of places for an economical number. The next step, though, was to recognize that SCPC has its limits. I have one channel. I get to send audio one way. With a multiple channels per carrier system, we then could enable ourselves to add other content. The beauty of that, you may have seen on the previous slide, my FedEx. We actually, for a while, were shipping out all the spots for a week via FedEx, and then they'd load them up on the weekend, and then you're set for the week. So we were using a wide area, sneaker net. Different technology. We regionalized the network, which meant we started wanting to play spots locally with this MCPC technology. And that allowed us to add a lot of flexibility. We started with a Wagner system. I ran into the ex-president of Wagner too long ago today. It was fun. And it allowed us to do that. As we kind of started worrying about Wagner's viability, we went to Pico Digital, which is now XDS, and went to a whole new system. What we gained there was the ability to have both C and KU band satellite on the same receiver with about 1/10 of a second transition between. So suddenly we were no longer worried about an outage, because if you lose one satellite for, I don't know, sun transit outage or something, it'll switch over in 1/10 of a second, and you don't have to worry about it. So that was pretty nice. The last thing that EMF did on the satellite side was to add a VSAT network with NewTek to do backhaul and do that remote control via satellite. Again, using TDM technology, being able to stuff a whole lot of data back and forth and control the whole network that way. And with that mode, frankly, the EMF was able to grow to literally 1,000 signals. But during that time, we just kept thinking, what's next? How are we going to get there? So one idea we had was, we're tired of taking this whole rack of equipment to every site. What if we could put that all in a single box? And we called the idea of a station in a box. But the idea is, what if I had a satellite receiver, local playback, audio processing, remote control, maybe even EAS, all in a single box? So we built a proof of concept, an entire radio station in a tower case. Worked great. Loved it. Meanwhile, our friends at the FCC decided to give away the lower half of the C-band. And we started going, this just became a higher priority. Suddenly, this is really, really important because we don't know what they're going to do. So we started experimenting with Starlink and other low Earth orbit technologies, found it worked pretty well. There are some challenges, some issues with it. Probably the biggest, weather-related. You mentioned this morning, Steve, about the daily or sometimes weekly updates or whatever it is we're doing that'll cause some problems. So those are entertaining. But there's also the sky shadow, I call it. So if you mount a Starlink dish too close to your transmitter tower, the tower itself becomes a shadow to block the access to those LEO satellites. That can be a problem. So you need to be thinking about that if you're using something like that in a LEO-based system. Other factors we were looking at is market demand. With MCPC, we had the ability to go local programming wherever we needed to. If you have a news event or something, we could easily do that. But what if we wanted to do, 2 different morning shows at the same time in 5 markets? Or what if we wanted to do 50 markets or 100 markets? How about also compression? We're sending everything compressed. Do we have to? I'd really rather not. Suddenly we realize that we have reached an era where technology allows us to be transport agnostic. I don't really care how it gets there. I just want to get it there. I don't really care how many times I send it. I could send it once or twice or 10 times and put it all together at the transmitter site. And it just makes a lot more sense than this old way of doing things, which was a one-to-one or one-to-many technology. Plus, with synchronization, if one path has a lot of latency and the other doesn't, I don't care anymore, because I can now digitally synchronize those signals and make them sound like one. And for the first time ever, one of our systems can fail and the audience is not the first one to know. I am. That makes a big difference. I loved that. So that really made me happy. So you may have heard earlier the presentation Bud and Cloud Junction did, Steve as well, on SD-WAN. So what EMF did is, as we started to take all these factors in, we started developing our own SD-WAN system and began to build that in. And so as of this moment, we can put all technology we want in a single box. I put a blurred out picture of a NUC, or next unit of computing, up there. And the reason it's blurred is it really doesn't matter what brand I buy, what model I buy. You were talking Raspberry Pis this morning. You just need some computing power. And since they're inexpensive, why not have 2 or 3 or 4 at a site? And then you have redundancy that way too. And throw a few in the truck. So if something breaks, I've got another one right there. Easy to do. The other thing that we gained is transport redundancy became essential. Not just gained, but we learned that we had to have transport redundancy because of those kinds of outages. Verizon decides they want to shut off for an hour, backhoe fade, whatever it might be. So every site needs at least two. And if it's a major market or something I really care about even more, 3 or 4 or 5 different paths for that signal to get. Again, because I'm transport agnostic, suddenly it doesn't matter anymore, and I can continue to add those. Another thing we were able to do is think through, what about the backbone of whoever my providers are? If we've got a copper backbone and a fiber backbone, now I don't even care if the backbone fails, because one of my systems is probably going to stay up. So just thinking through all of those pieces really makes a difference. So the beauty of all of this is that ultimately it doesn't matter anymore. Anything goes. You can literally run your signal from wherever to wherever. Doesn't matter which direction it's going. Doesn't matter how it's getting there. And just imagine the possibilities if, okay, my microwave STL failed. Oh well, I'll go fix it tomorrow. That's pretty cool. So anyway.
Thank you, Sam. And so Andy got hurt. Andy's presentation is still in here, and I will run through it because it's something that kind of plays in with where we've built up to, and that is how to transport audio. We've talked about the importance of redundancy, SD-WANs, and the difference this morning with Cloud Junction. We learned how to make it seamless as opposed to just using a feature that may be in your existing router to use another circuit as a backup. So one thing that Andy did, because this is stuff, if you know Andy, you know where I'm coming from, but Andy likes to experiment and play with things. What he tried to do here is, and I'm having a little trouble seeing the screen here, but what he tried to do is go to a venue and transport, I believe, 12 channels of audio back to his studio and do the mix down at his studio. He did the mix down there and broadcast stereo on the air. So the problem with this is there isn't a lot of compatibility on the product. There's the professional side that he talks about here, and the broadcast side. So again, I'm going to keep on time here. I'm going to go through this somewhat quickly. The broadcast tech, the hardware is designed to be reliable, enduring, modular, easy. It's usually stereo, right? Many channels of stereo. But on the music tech side, it's a little bit different. It's very different, and it may not always be compatible with the broadcast tech. So what he did here is, and I'm going to scoot ahead. Well, actually, this is the slide that I wanted. He used software called Omnibus and Live 2. He had that set up at the venue with a Behringer, right? So he had a Behringer X32 at the venue, sending 12 channels of audio back to the studio by using Omnibus and Live 2. I haven't used that yet. I asked him how big the path was. He said, it was about 100 meg. And I'm like, okay, so he's using that much bandwidth. So you have to have a good path for that. But he was able to get that audio back on his X32 at the studio, where he actually did the mix there, and then outputted it as stereo into his live wire system. And that's what was broadcast on the air. How I lived through this was he kept on texting me all through the evening that he was doing this. All right, I found this and I've got to do this. And he made it work. Where does this become helpful? This becomes helpful when you may need to do a mix at a remote location. You don't want to transport talent in. There are ways, I understand, that different band members can be in different locations, and that would require a bigger version of this software to do that. But this is where we're at now. We talked about leased lines, and we talked about using IP connectivity and satellite connectivity. And here we are. We're feeding multi-channel audio over the internet, and we're getting it to the studio or wherever we want it to go. And we're just using regular computers and regular hardware for that. So it has definitely come a long way. He did have some conclusions. that in recommendations, he talks about providing native load balancing support, multiple ISPs, cross-locking. I say Cloud Junction because that's what we saw this morning that works. Raise listen to channels to 32 streams. Okay. And he's the expert on that. Provide data payload meter and monitoring, and then watch your bit error rate, collisions and events, and continue to integrate Omnibus into the Live 2 for ease of use. This is something he was doing. I tried to do best I can to present this to you guys, but if anybody would like more information on what he did here, he's more than happy to talk to anybody about this. And he could show you a lot of different things that he did. And that's just the way Andy is. He's always experimenting and always coming up with, how to use technology and how to expose it, how to just make it perform better. So, any questions on anything any of us have discussed? Bueller? I can't call on Steve Schultes. Anybody have some experiences that they want to share in the time left on how they've transported data?
Yeah, but I can add that,
Yeah.
Though I left EMF just after we had started, we've now been running, the Nashville station, has been running that SD-WAN technology for a year. It's been rock solid, with no issues. It was our beta test prototype site. And, the crew's been building 10 to 20 a week. And it's getting built out, and we won't need satellite very quickly. So it's pretty amazing how the technology has enabled that kind of thing.
What's next? I don't have that answer right now, but
Neither do I.
Yeah. So, but what's that?
Wait a week.
Yeah. Jim says wait a week. So, all right. Any other comments, questions? No? Thank you very much for being here.
Thank you very much.
Appreciate it.